Hello, and welcome to the next video in my series on basic statistics. Now, a few things before we get started. Number one, if you're watching this video because you are having problems in a class right now, I want you to stay positive and keep your chin up. If you're watching this, it means you have come pretty far in your education up to this point, and you may have just hit a rough patch. So I know with the right amount of hard work, practice, and perseverance, you can get through it. I have faith in you, and so should you. Number two, please feel free to follow me here on YouTube and or on Twitter. That way when I upload a video, you know about it. And on the topic of the video, if you'd like it, please give it a thumbs up. That does encourage me to keep making them if I know they are beneficial. On the flip side, if you think there is something I can do better, please leave a comment below the video and I will try to incorporate that in the future videos. And finally, just keep in mind that these videos are geared towards individuals who are relatively new to stats, so I will just be going over the very basics, because I believe that a firm foundation of basic concepts makes the harder stuff later on a whole lot easier. So all that being said, let's go ahead and get started. Now in this video, we're going to continue our discussion of the binomial distribution. In previous videos, we talked about how to find the cumulative and sort of exact probability at a given value. So we were looking at what is the probability of making a certain number of sales on any given day. That was our previous video. And we looked at what's the probability that a salesperson made, 8 or more sales in a given day. And that is cumulative probability. Now in this one, this is actually going to be a fairly quick video, I think, and we're going to talk about how to find the mean and the standard deviation of a binomial distribution. So I talked about expected value and things of that nature in previous videos, but that's really kind of what this is. We are finding the expected value of a discrete random variable, but it's a binomial random variable, so it only has 2 outcomes, and that's what makes it special. In one video we talked about the outcomes on the roll of a die. Well, that has 6 outcomes. In another video we talked about the possible outcomes on a class evaluation. So very dissatisfied, dissatisfied, neutral, satisfied, and very satisfied. Well, that's 5 outcomes. So remember, in the binomial we only have 2 outcomes. So we find the mean and standard deviation a bit differently. So let's go ahead and look at the problem. So this is just a repeat of the same problem we had in the last video, but of course we're going to find the mean and standard deviation in it. So our example was, as a sales manager, you analyze the sales records for all salespersons under your guidance. That makes sense. So you're interested in 2 of your employees. Joan has a success rate of 75%. So when she makes a sales call, the chance that she gets the sale is 75%. And she averages about 10 calls per day. Now Margot, on the other hand, has a success rate of 45%. So her chance of making a sale when she makes a sales call is only 45%. But she averages 16 calls per day. And in the previous video, we were asking this question. What is the probability that each salesperson makes at least 6 sales on any given day? Because that was our sales quota. We wanted our salespersons to make at least 6 sales per day. And based on Joan's success rate and number of calls and Margot's success rate and number of calls, we were able to find the probability that each one of them makes at least 6 sales on any given day using cumulative probability in the binomial distribution. So in this video, we're going to talk about mean and standard deviation. So the question is, what is the mean and standard deviation of the number of daily sales for each employee? So here was Joan's distribution. So N, again, is the number of calls she makes per day, so 10, and P is her success rate, which is 0.75 or 75%. So we can see along the bottom, we have the number of daily sales, 0, 1, 2, 3, 4, all the way up to 10. On the left-hand side, on that axis, we have the probability. So you can see if you read this, the probability of making 8 sales on any given day is about 0.28 or 0.27 or so. So the bar height is just the probability for that many sales on any given day. Now Margot's look like this. Now you can tell that she makes many more calls per day, all the way up to 16. So she can make anywhere from 0 sales all the way up to 16 sales. Now of course those outcomes are very unlikely, and you can see that by looking at the bars in this graph. The probability of making 0 sales on any given day is so small that you can't even see the bar height. It's there, but it's so small you can't even see it. The same thing for 14, 15, and 16, they're on the right. So in the middle, you can see that the highest probability is for making 7 sales. And then 6 and 8 are pretty close to that. But her probabilities only go up to just below 0.2. So it's a little bit more spread out because, of course, she's making more calls. So our question is, what is the mean and standard deviation of those two graphs? Just a reminder, N is the number of trials, in this case calls, that each person makes. P is the probability of success for a sale in any given call. So that would be 0.75 for Joan and 0.45 for Margot. Now Q is just 1 minus P. That's the probability of failure, in this case not making the sale for any call. Because remember, the probabilities must add up to 1. There are only 2 of them, and they are mutually exclusive. So if P is 0.75, then what does Q have to be? Well, 0.25. Okay? And that's just a characteristic of the binomial distribution. So we'll summarize this in a chart. So Joan makes on average 10 calls per day. Her probability of success, P, is 0.75. Therefore, the probability of failure is 0.25. For Margot, she makes on average 16 calls per day. Her probability of success is 0.45. Therefore, her probability of failure is 0.55. So we just put that in a chart so you can see where we're getting our numbers from. So let's talk about the mean. And remember, since we're dealing with a discrete variable, it's also the expected value. So again, if you want to look at my video on expected value, I go into a lot more detail about expected value. But remember, what distinguishes this video from that video is that the experiments in the previous video on expected value had more than 2 outcomes. So a die roll had 6 outcomes, a course evaluation had 5 outcomes, etc. This only has 2 outcomes, success and failure, sale or no sale. But it's the same basic idea. So here is the formula for finding the mean or expected value of the binomial distribution. So remember, we have mu, which is the U-looking character. Again, don't go into stats class and say moo like a cow. So mu equals N times P. And remember that N is our number of trials and P is our probability of success. So we'll put our chart back up. You can see that for Joan, N was 10, P was 0.75, and for Margot, N was 16 and P was 0.45. So let's look at Joan's mean number of sales, daily sales. So mu equals 10, which is her N, times 0.75, which is her probability of success, and that equals 0.75. Let's look at Margot. Mu equals 16, which is her number of calls per day, times 0.45, which is her success probability, and that equals 7.2. Therefore, we expect 7.5 sales per day from Joan. And we expect 7.2 sales per day from Margot. And that is their mean. So 7.5 mean sales per day for Joan, 7.2 mean sales for Margot. Now notice those are actually fairly close. But again, the number of calls are different, the probability of success is different, and things like that. The reason Margot is so close to Joan is because she makes so many more calls on any given day. So the fact that her success rate is lower is compensated for by the number of calls she makes. Okay, so there's our mean. Now we know that we're looking at a distribution. The mean doesn't tell a whole story. We have to figure out what the standard deviation or what the variation is from that mean. So let's do the binomial standard deviation. The formula for this is actually fairly simple too. You just have to do a little bit of different things in your calculator. So the standard deviation, which is, remember, sigma, equals the square root of n times p times q. And of course, we already have those numbers. We know what n is, we know what p is, we know what q is. So here's our chart again. So let's figure out Joan's daily sales standard deviation. So that is sigma equals the square root of 10 times 0.75 times 0.25. And that equals 1.37 sales. So the standard deviation for Joan is 1.37 sales per day. Now Margot's is sigma equals the square root of 16 times 0.45 times 0.55. And that equals 1.99. So you can see that Margot's standard deviation is higher than Joan's standard deviation. And that's, of course, because of her number of calls she makes and her success rate. But that's how you figure out the standard deviation. It's really that simple. So, what is the mean and standard deviation for each employee? So there's Joan's chart and there's Margot's chart. So for Joan, her expected value or expected number of sales per day is 7.5 daily sales. If you look at her graph, you can see that's right between, obviously, the 7 and the 8, which is right between the two highest bars for Joan. Now, if you look at her standard deviation, 1.37 daily sales, we didn't do it in this graph because it would make the graph messy, but you can think in terms of one deviation away from 7.5 in each direction, and maybe two deviations away from 7.5 in each direction, and so on. And you can see that almost all of her daily sales fall within plus or minus 3 deviations. Now let's look at Margot's. So her mean is 7.2. So if we look at her chart, we can see that it's pretty much right on the 7. So it's on the 7, but a little bit closer towards 8, which again is the next highest bar in her distribution. So 7.2 sales for Margot is what we expect. And of course, the standard deviation is 1.99. So we have to go almost 2 sales beyond 7.2 to capture Margot's distribution. So the standard deviation is a bit wider. And if you look at her graph, just visually look at it, that should make sense. The probabilities are lower and they're more spread out. And again, that's because she makes 16 calls per day. And of course, her probability of success is 0.45, which is pretty close to the middle there at 50% or so. So you can look at the mean and standard deviation to see the number of expected sales per day, and then how far out from that mean we will sort of capture that probability. Now here's another example. In a May 2012 Gallup poll, 46% of Americans said the following statement most closely matched their views. God created human beings pretty much in their present form at one time within the past 10,000 years or so. Now, if you wanted to replicate this poll in 2013 with a sample size of 78 similar people as that original poll, what is the expected number of respondents that would agree with this statement? So if you replicated this poll, asked the same questions, but because of time and money you only sampled 78 people, how many of those 78 would you expect to answer the same way? So we're trying to find the mean. Now, if you're interested, you can pause this video and look at the link down there at the bottom. You can actually go to that Gallup poll, or if you go to the Gallup.com website, I think it's there on the front. Okay, so our mean, mu, is just n times p. So in this example, our n is 78 because our sample was 78 people. Times p, so our probability of, in this case, success was 0.46 because 46% of people agreed with it when Gallup did it. And we do that multiplication and we have 35.88, or about 36. So out of our 78 people, we would expect to have about 36 of them agree with that statement if the probability is the same as the original Gallup poll. Now, this is where the power of binomial distributions and distributions in general come into play. If we were to do this, but we got, I don't know, let's say 44 people that agreed with that statement. Well, how out of the ordinary is that compared to Gallup? What is the probability of getting 44 people that agree versus 36, which is what we expected? We're going to look at that question in future videos. But now let's do the standard deviation. So we'll move that over. Now look at the standard deviation. We just have the square root of n times p times q. So that is 78 times 0.46 times 0.54. And that gives us a standard deviation of 4.4 people. And again, because we're dealing with human beings here, parts of a human being don't make any sense, if they're alive at least. So we kind of do some rounding here. So in the mean we said about 36. For the standard deviation we could say around 4 or so, but that just depends on how your instructor wants you to use these in the problem. But regardless, you can see that the standard deviation is about 4.4. Now remember what I said, if we had like 44 people that agreed with this statement, what would that be? That would be almost 2 standard deviations above our expected value. If our mean is 36, that's what we expect, but in our sample or something like that, in another sample, we get 44. Well, we have to ask ourselves, what is the probability of getting that many people versus 36? And if you look at your standard deviation, we can see that, again, that's almost 2 standard deviations above the mean that we would expect. So that's how we can use this in other binomial distributions. Okay, just to review, remember that n is the number of trials, and in our previous case was the number of calls per day. P is the probability of success in any trial. So that was the probability of making a successful sale. Q is just 1 minus P, the probability of failure. And that's just because P and Q must add up to 1. So our mean is just n times P, very simple. Our standard deviation is the square root of n times P times Q. Okay, so that wraps up the next video on the binomial distribution. So, again, in previous videos we talked about each individual probability for each outcome. We talked about the cumulative probability for sections of our distribution. So we talked about if we wanted to know the probability of 6 or more sales, we had to find the probability of 5 or less and then subtract that from 1. So in this video we talked about just the mean or expected value in our distribution, and its accompanying standard deviation. And that helps us answer more complex questions about distributions and experiments or polls that we run or anything like that. We can determine how out of the ordinary or how far away from the mean our results might be, and whether that deviation from what we expect is due to chance alone or something else. So again, if you're watching this video because you are having problems in a class right now, I want you to stay positive and keep your head up. I have faith in you, and so should you. The fact that you're here watching this video, trying to improve yourself in your education, is what matters. So stay positive, keep working hard, and you can get through it. Remember, if you like the video, please give it a thumbs up, because that encourages me to keep making them, and the same thing for other videos you watch on YouTube or where else. If we get thumbs up, we want to keep making them for you. On the flip side, if you think there is something we can do better, please leave a constructive comment below the video, and I'll try to work that into future videos. And finally, I want you to have fun in your studies, because a love of learning is what drives me to do what I do, and I hope that comes off to you. So I wish you the best of luck in your studies, and I look forward to seeing you again next time.